over to Jeremy Wilson. Please give Jeremy a round of applause. Thank you.
Is it working now? Fantastic. I got applause before I even did anything. That's very exciting. Thank you, Marlena. How's everybody doing tonight? It's a lovely day. Been to Engineering Expo, maybe. Hope you've enjoyed your first few weeks of classes. As Marlena mentioned, my name is Jeremy Wilson, and I'm very proud to represent the Chemical Engineering Department here to you today. Where are my notes? Y'all flatter me. Marlena's done much of this for me already, but I do want to extend a very earnest welcome to you. For many of you, last around for a while, maybe just for the sake of time. I do want to extend a very warm welcome to you from Virginia Tech and from the College of Engineering. You're in a very, very special place. I've been here for 2 years. I'm very proud to call Blacksburg home now and to call the College of Engineering a place where I belong. And I think you'll find that too. Whatever you end up studying, you're going to get a great education and you're going to have so many amazing opportunities through your program. So I do want to first recognize the fact that we're coming at this from very different perspectives. Some of you are here because you know you want to do chemical engineering, and I'm so happy to hear that, and I'm so excited to share parts of our program with you. Some of you, maybe you're unsure. Maybe you've heard a little bit about chemical engineering, maybe you might be interested in it, but you're not entirely certain. Welcome. I'm so excited, too, to share more about our program with you and help you maybe discover if this is right for you. And for some of you, maybe you know you want to do something else. And that's absolutely okay too. I hope that some of the information I share with you will help you in case you're ever having a conversation with a friend, a peer, or a family member about different engineering opportunities. Is it showing exactly what's on my screen? Yes. Fantastic. It's been a while since I've had to give a presentation. So I think what we need to start with is a very simple question, and one which you may or may not have considered, which is, what's chemical engineering? Kind of need to answer that before we get started with anything, right? You probably have some idea, right? What sort of images come to your mind when you hear the words chemical engineering? I'll take any ideas. Labs. Chemicals. Pharmacies, sure. Lots of different ideas, right? And that's going to be a bit of a recurring theme throughout this is it's hard to pin down what is chemical engineering. Now, full disclosure, I'm not a chemical engineer, not by training, and so I've had to learn a lot about this profession over the last year, and I've heard a lot of different definitions about what exactly it is. I'll share with you the one that I like the most and which makes the most sense to me in context. And that's our department head's definition. Making and moving the molecules that the world needs. And I think there's a few things that we can parse out of here. There's the making, right? Products are made of things, right? Somebody has to make those things, whether it's the chair you're sitting in, the bottle that you're drinking water out of, the bed that you're gonna lay in tonight, I hope. Don't do any all-nighters yet. There's the making. There's the moving, right? How do we get things from place A to place B in a way that's efficient, timely, and safe, especially when we're handling some unstable things, right? Potentially dangerous things. And I think, too, it's worth emphasizing that we do things and we make things that the world needs. The world needs chemical engineers. Another theme that I hope will come up through this presentation. We need people like you to come in and become chemical engineers to help solve a myriad of problems that we face as a world and as a society. So something worth considering when we talk about chemical engineering, when we talk about making things, and when we talk about moving things, we're talking about things that are happening on two very interesting and very different sets of parameters. On the one hand, you may be thinking, okay, we're making giant reactors that are creating whatever chemical you can think of, peroxide, I used that the other day. But we're making things that are 10 nanometers in size. We're just making lots and lots and lots of them, right? Somebody's got to make enough toothpaste for everyone. Think about that. That's a lot of toothpaste, right? A chemist may be able to synthesize the chemicals in a lab, but somebody's got to make it en masse. That's where the chemical engineer steps in. So the natural next question is, okay, we've got a few different examples of what chemical engineers might do, where we might see them, but really, Jeremy, you're being very abstract here. Give us some concrete examples. All right. How about in food? What is food? It's chemicals, right? Chemicals bound together in certain ways, right? Foods are made by chemical engineers at the end of the day. We have students every year who work with groups like PepsiCo, Frito-Lay, all sorts of companies you can imagine in the production of food and other consumer goods. I mentioned toothpaste, right? But anything you can find in your house that is made out of chemicals was touched by a chemical engineer. All right, Jeremy, that's all well and good. What else have you got for me? Well, let me turn the page in my notes so I know what my next slide has on it. Somebody mentioned pharmacy when I asked about what chemical engineers do, and I'm really happy to hear that because, yeah, chemical engineers make medication, make vaccines, make everything you do in the healthcare industry, right? Not necessarily something you think about. Maybe that's more the realm of a biologist or a chemist. But again, somebody has to make enough for everyone. Think about the COVID vaccine. We lived through that. That's our generational trauma. Still recovering. But think about the creation of that vaccine, right? Who invented it? Well, a group of biologists, a group of chemists working together in this lab created maybe one, maybe two. That's not enough. Somebody had to come in and figure out a process to make billions, right? Again, the role of the chemical engineer. What else? Well, how about in energy? Whether in sustainable or in traditional models, who makes enough for everybody at the end of the day, enough for the world? The chemical engineer. And here's something very interesting that I didn't learn until really I got knee-deep into this program is we're also beginning to see increasingly chemical engineering, and all of you computer science folks probably perked up a little bit when they saw the slides. We're seeing it increasingly being used in conjunction with computer science, with data, machine learning, with algorithms to solve chemical and chemical engineering problems. That's actually a really interesting aspect of our department that I'll talk about a little bit later. So Jeremy, sounds like chemical engineers do a lot of different stuff. Yeah. That's why I've seen them a few times be called the universal engineer. The chemical engineering knowledge base is enormously broad and enormously applicable to an enormous number of industries and pathways that you can choose. Chemical engineering arms you with the tools to carve a career for yourself in almost any manner you want to do. To give you sort of a sense of that, I pulled these from the last 2 years, some of the job titles that our alumni have now. Process engineer is probably the most common one, but you see things like nuclear engineer. That pops up, actually, we've got 8 in the last 2 years who are nuclear engineers. Environmental consultant, supply chain engineers working in that transportation of molecules that I mentioned earlier. Cell engineers, I don't know what they do, but that sounds neat. Drug development, water treatment, energy. An enormous diversity of careers and an enormous diversity of opportunities, right? Okay, so that's all well and good, Jeremy. You're talking a little too much. Let's move on to what am I doing in this major? That's a great question. So broadly speaking, the chemical engineering curriculum includes The general engineering curriculum, you're all here for your foundations classes. Some of you are exploring engineering more generally. You've got your intro English classes, you've got whatever else is common to the engineering program. We require 2 years of chemistry. You may be surprised to learn that for chemical engineering, you do have to study some chemistry. That's Gen Chem 1, Gen Chem 2, Orgo 1, Orgo 2, with all the labs except for Orgo 2 lab. 2 years of math. Calc 1, Calc 2, differential equations, linear algebra, multivariable calculus. A lot of you will be in a lot of these classes already. And we require a year of physics. Physics 1, Physics 2. So what about the actual chemical engineering stuff? You begin that in your second year, starting with a class called Mass and Energy Balances, proceeding through thermodynamics and into really some of the heavier topics, which broadly speaking, follow one of these 3 areas. Reactions, right? Creating things. How do we make the molecules and the products that people need? How do we move it around, right? You have to move it from place A to place B in a way that's safe, efficient, and the third word, right? So we study not only how do we move mass, but also how does energy work with that, right? And we talk about scale, right? I mentioned, you got to make a lot of toothpaste, right? You might start with a very small experiment, a very small production apparatus, but you've got to figure out how to make that at scale. That's generally the focus of our senior year. Oh, fantastic. Another important aspect of our program is called the Unit Operations Lab, UO Lab. This is really one of the capstones of our program in which you get to go and spend an intensive summer working with real-world lab equipment like what a chemical engineer will use in the field. Traditionally, this is done in the summer before your senior year. We're exploring a couple of other options surrounding that. If you're interested in other options, talk to me about it. But I'd like to very briefly just share a video that the department cut a couple of weeks ago about that. Let me see if I can make this work. Do I need to change anything, Marlena? All right.
We're in the Chemical Engineering Unit Operations Lab, which is to test what you've learned in all of your chemical engineering classes and kind of apply the different unit operations you've learned about, such as heat exchange, process control, separations, reactor design, and see them actually happening and how the theory applies and works out in real experimentation.
It's a required course for the chemical engineering degree. It's actually our only laboratory course. They're going to do 6 experiments over the course of about 4.5 weeks. But it's very, very time intensive, and so what they're doing is they're devoting pretty much 40 hours a week. Either they're working in the lab itself, or they're writing up the lab reports or preparing for the next lab. So it's equivalent to a full-time job.
It does prepare you for kind of the workload, I would say, of having to bounce between different projects, because you're not going to stick with one, you'll look at multiple.
The best part is the fact that what I learned in class, what I saw on paper, now I have like equipment machine that can go collect real world data and then take the theory, which is the model, and apply it to the real world and see how consistent the theory is.
We've got 6 groups running right now, so we've got 6 different experiments. Students have been introduced to the equipment, but now they're actually trying to figure out how to operate it. So in the morning, they come in and they try to figure out how to turn it on and get everything to work. And by this point in time in the afternoon, they've actually kind of figured out what they're doing. And so now they're actually doing some nice data collection.
So the lab we're currently working on is the ammonia stripping column. So we're trying to strip ammonia gas from a weak ammonium hydroxide solution. In the real world, ammonia stripping is commonly used for wastewater treatment.
The key thing that I think is really important here is that they work together as a team, they divide up the projects that they're working on, good time management, and that they develop oral and written communication skills. Companies that hire our graduates know that our students can do the equations. What they really want to see is, do they have those professional skills? And so we try to emphasize those at the same time.
Fantastic. So what we really hope to do with UO Lab is provide you with an in-depth experiential learning opportunity. And we're really proud of the fact as well that, next slide. Next slide. We are very proud of the fact that we also offer the opportunity to take the Unit Operations Lab abroad in Copenhagen, Denmark, or in Bochum, Germany. It's hard to study abroad in engineering. The curriculum is just paced in such a way and interlocked in such a way, it's difficult. That's why we're really proud of this opportunity, and a lot of our students choose to take advantage of it. Speaking of opportunities in Chemie, I'd like to just share a few things you could do while you're studying chemical engineering to learn outside of the classroom, discover new aspects of the major that you might be interested in, and explore opportunities. First, you can kind of specialize. You can choose a branch of chemical engineering that you're particularly interested in and that you want to study in a little bit more depth. These are our 3 tracks. Currently, we've got Climate and Energy Solutions, which is, by the way, the first of its kind in the country. We've got Computational and Data Sciences, and we've got Healthcare Technologies. These align with some of the interests of our faculty members, the interests of the department, as well as when you look at the broader market and the broader world need, these are some of the major areas that you see. We also have room for minors. If you want to explore something maybe outside of chemical engineering, just specifically, we have students who minor in everything from green engineering to French to economics and everything in between. Our 3 most common ones are probably green engineering, biomedical engineering, and did I say nuclear already? Nuclear, green, biomedical. Those are our big 3. So we also have design teams. What are engineers if not builders, right? You create things. We have 2 major design teams. One is Chemie Cube, in which you work together in teams to build a shoebox-sized car powered entirely by chemical reactions. Our students on these design teams go to a national competition, and the day of, they learn how far the car has to go. So they've got to make some adjustments on the fly to make it work for that distance. We've also got Chemie Cube, wherein our students design a miniature chemical reactor that fits within a 1 foot by 1 foot by 1 foot cube. I believe this year they're doing a reactor to do carbon capture and carbon regeneration. So really interesting stuff. We have an extraordinary supportive student body, and that primarily comes in the form of AICHE, the American Institute of Chemical Engineers. Our student chapter is enormous. It encompasses most, but not all, chemical engineering students, and it provides opportunities for tutoring, mentorship, service, and social events. Fantastic organization. I believe they've won a couple of awards just for being great student organizations in the past prior to me coming here. Internships, co-ops. I spoke about experiential learning earlier. This is another great way to learn on the floor, get your hands dirty, and learn about chemical engineering. We are very proud of the fact that we lead the entire university in internships and co-ops. It's neck and neck with us in mechanical engineering, but I believe this year we're out on top. And this year, our class of 2024 worked with some of these companies that you've probably heard of: Clorox, DuPont, ExxonMobil. And some of these students got jobs. Internships and co-ops lead to jobs. It's a great opportunity for that. You can also conduct research. Anybody interested in doing some research while they're here? A few folks? Fantastic. That is a great opportunity, and I would highly encourage it no matter which department you end up in. About 30% of our students will do undergraduate research with one of our faculty members at some point. And our faculty are doing really cool stuff. In the top left, you'll see a COVID-stopping copper coating that was invented by Dr. Ducker in our department a few years ago. He was interested in ways to prevent the spread of the pandemic on common surfaces, right? In the bottom left, you'll see Dr. Rajagopalan and her students who are doing research in tissue regeneration. Top right is actually our department head's research in cardiac ultrasound agents. And in the bottom right, Dr. Karim is working with catalysis, discovering more efficient ways to generate green energy. And actually, I should have put this on here. Dr. Bortner's team just made like a collapsible wind turbine. That's neat. I don't know how that works, but it's cool stuff. So, in sum, ladies and gents, I think a question worth circling back around to is, Jeremy, you've laid all this out there. You've told us all about the curriculum. You've told us a little about what chemical engineering is, but why should I do it? Got a few things to pitch you. I'd like to go back to that idea of the universal engineer. If you get a degree in chemical engineering, you can transfer those skills to a truly enormous number of possible fields. We have students, as you saw, who go into everything from nuclear to environmental engineering and everything in between. And you can go with your chemical engineering in a few different other directions as well. You could go into the business side of things. We have folks who go on and do marketing in the chemical industry. We have students who become true experts in the process manufacturing field and are on the floor in production facilities for most of their career. We have students who go on to executive positions. And we have students who go into academia. About 5% of our students every year will go directly into a graduate program. I mentioned this earlier, but the world needs chemical engineers. Recently, the National Science Foundation sent out an article in which they called on Congress to fund more and encourage the training of chemical engineers to tackle some of the world's most pressing problems. Climate change is a thing. Maybe you want to help fight that. Chemical engineering could be your opportunity. Maybe you're concerned about the next big disease, or even just how do you more effectively deal with the common cold. Chemical engineers do that. Maybe you're interested in food efficiency, reducing food waste and making sure there are enough resources for everybody. Chemical engineers touch that as well. And finally, you can build a very meaningful career out of this. Let's call a spade. Salary, right? Median starting salary as of last year is about $74,000. Median salary for all chemical engineers, according to AICHE, is about $150,000. There is a high demand for our positions. I have heard a lot of different anecdotes of our students being grabbed and pulled into booths at Engineering Expo because there is a need for chemical engineers. It's also a global industry. Our students and our alumni get the chance to travel the globe peddling their skills at different manufacturing plants, different buyers, different salespeople. If you want to travel, not a bad way to go. It's future-proof. I don't think there's ever not going to be need for chemical engineers. This is a field that just grows by the day. And finally, I've already mentioned this and I'll stop mentioning it. You've got a really flexible career path. You can do an enormous amount of things with chemical engineering. So, not yet. As I finish up, ladies and gents, I do want to say again, thank you so much for your time, especially those of you who maybe this isn't for you and maybe you came for another program. I really appreciate it. One way or another, ladies and gentlemen, welcome to the College of Engineering and welcome home, Hokies.
Good evening and welcome again to the College of Engineering Hall. Thank you. Thank you, God. My name is Virgilio Centeno. I'm the Assistant Department Head in Electrical and Computer Engineering. I'm also a very proud triple hockey. I got degrees from here in 1985, 1988, and 1995. Okay? So I've been there where you are. And we know that, you're here, most of you decided what you want to do, but some of you are interested to seeing what else is out there and see if we want to change and all that. And that's the purpose of these things. And having chemical engineering present before that, remind me that when I started college, I started as chemistry major, then moved to chemical engineering, and then moved to electrical engineering. And then inside electrical engineering, I moved from the communications field to the energy field. So, there's flexibility at Virginia Tech. There's many fields. And you're here and you're starting. And believe it or not, the world is ahead of you. Okay? This coming from those who see the world behind us. Okay? But that's a great time to be. It's a great time to learn. And it's a great time that if you find something you like it better, you could go to it, switch, and make a life out of it, okay? You have plenty of time to do that. Yeah, it may cost you a little bit more depending how much you switch, but you're talking about the rest of your lives. So it's something you should really think about it. So let me tell you what we have on electrical engineering for you and see if later we can answer some of the questions you have, okay? In electrical engineering is the department that has actually 2 degree programs, the electrical engineering and the computer engineering. Back in my time, when I graduated back in '85, I graduated as an electrical engineering, and computer engineering was starting. It wasn't quite there. Nowadays, those guys, my colleagues in computer and all that, they're about 60 to 70% of the department. That's where everybody's going, right? Computers, the future, and all that. But the rest of the department is still there. We still have our computer, we still have our electrical engineering degree. Now, here's where we go slightly different than most other universities. Inside of each of those degrees, we offer 6 majors, okay? A major, we're talking about something that, you know, you get a degree from here and say, oh, you have a bachelor in electrical computer engineering, major in, and this thing is in your diploma. This is something new. We have, what, 5, 7 years since we started with this, okay? The previous department head realized that over, you know, more than 30 years, we haven't changed the curriculum. And he went like, what? You know, the whole world is changing and we haven't changed. This is the kind of change we came up with. We make it very flexible and sort of dynamic so that we try to adequate to the students, meaning we know that the students are not sure and they want variation. So let's show them the variation, allow them the flexibility to change. And that's where we have the different majors on it. And we try to make it easier for you to change in the majors, okay? So, how we do it? Well, the first 2 years are about the same. The semester where you take some courses will change whether you want to go into computer, you want to go into more electrical type things. But still, the flexibility is there. You may have to come a summer to catch up if you decided to jump from electrical to computer or the other way around. But the first 2 years, you're going to get the same courses. And we learn from the past. We used to have that where, you know, okay, you have to take the same courses, but we didn't enforce them when. And we have computer engineers taking 2nd year electrical engineering classes the last semester here because they didn't want to take that class. Okay, now we say, no. You're not going to move past that 2nd year without taking the common base. And it's not to torture, it's because we think you need that knowledge to make better choices and to get more out of the knowledge you get from the other courses you're taking. So we're going to make you take those, but you have that. So after you complete your first 2 years, okay, you get to decide which way you're going to go, electrical or computer, although by then most of you will have that decision made. You will have a sophomore design project where we want you to use all the knowledge you acquire your first 2 years to do small projects. And we're looking at it. We're looking at it for 2 reasons. One is, do you acquire the knowledge you wanted? We want it for you to have to move on. 2, are we doing a good job at it? Okay. If you have it, but not quite the way we want it, then we start reviewing. We go on, try to fix the way we're doing it and give you better education on that. Okay. Now, after that, you will decide to go full electrical, full computer, and pick a major in one of those, okay? And even in those majors, up to the 3rd year, you can swap majors. And still, you can graduate in 4 years, Okay? So we try to keep that flexibility there. And that's why we're a little bit rigid when you take your courses and all that. But even then, we have some flexibility. Okay? And then, to give you a little bit more freedom, we allow what we call a secondary focus. So I want to be in computer, but I like that part that they're doing on cybersecurity on the electrical side. Can I take some courses on that? Yes, you have a secondary focus. No, I like the minor in green engineering that the college offers. Yes, that could be your secondary focus. You can take that. So we try to give you flexibility so you have some breadth, and at the same time, okay, you have some choices on things. And we worked very hard this past spring and last fall with the state of Virginia to reduce the requirement for courses. So starting next year, you need 120 credits to get a degree in electrical or computer engineering only. But guess what? We work really hard and a lot of help from the college to get it there. If we get it approved and all that, it always go back 1 year and may apply to most of you there. So we've given you a lot of knowledge. We took some choices on, if you want to take wine tasting or tennis or something like that for credit for computer electrical engineering. No. But we kept our bases there and we gave you flexibility and you're going to have there. So if you go into this, if you go computer engineering, what is it that you do? Well, you design, test, integrate computer systems. Okay? What kind of majors can you have there? Well, we have general computer engineering. That means it's the same degree as you may get in any other university. It's your general computer engineering. But you can also specialize. Okay? Usually you want to specialize, you go to grad school and you try to focus on given things. Now, here you can begin to specialize as an undergrad. So you can go into chip scale integration. What is that? Well, if I want to build a phone like this, I can put a bunch of chips together to do the different functions, or I can design a single chip that includes most of those functions and make it a lot easier to manufacture, cheaper to sell these things. And that's the kind of things you can focus on, okay? Bringing the chips all into a single scale so that you can create systems with them. We also have control and robotics and autonomy. In my times, it used to be called control, okay? But what is it that you control? Anything that needs electricity to move or to send energy, it can be controlled. It could be a robot, okay, and we have those. It could be an electric car that drives by itself. You need a bunch of sensors and things like that. You need to know something on that. I'm a avid of my one wheel. I have a one wheel I like to take on the weekends to kind of relax and relax. I love the thing, and I use it for my students to bring the control, because the thing, is a board with a wheel in the middle. You step on it, and the control turns on, and standing there, the control keeps you there. It's electronic. It's not that hard. An old guy can do it, right? So it's not that hard because of the electrical engineering that goes into it, the computer science that goes into it, the chemistry that, helps us get the batteries and all those things in there. It's all there, but that's the kind of things you can come up. Control and robotics help you do those things and others. Machine learning, that's where we try to compete with computer science, right? We have learned in the past few decades how the brain works, and we're trying to make sure machines work similar way, okay? So we give machines usually a little data to try to figure out what they do. I can look out there and see your faces and ID what, you are. Some of you, the hair is too long, so others are blondes and things like that, okay? If you're a computer, what do you see? You see a bunch of pixels. And how you interpret that as being a person, a cat, a mouse, or whatever like that, well, that's where your machine learning goes into place. But it's not different than the way your brain does it, okay? All I see is a reflection of eyes coming into my eyes, and I make a focus of what I want to see, and my brain identifies that, oh, that's a student, and he's fallen asleep, But that's machine learning, is the brain learning brought down. You have network and cybersecurity. It has become very important now. We communicate with everybody, everywhere, and all that, but it's subject to people abusing of the system, and that's where cybersecurity comes from. We can make things secure and all that. I work in power systems, energy fields. For us, this is very important. Last thing we want is for the power to go out, okay? Because that will affect everybody. You also have software system. That's when you want to build a whole system that gives you something. And I'm running my time up. So on the electrical side, what we have? General electrical engineering. You're not decided what you want to do. You can stick to that and then go to grad school or wait until your last year, take a couple of courses and find your job on that. You have applied electromagnetics. If you love math, that's a good one. Applied electromagnetics takes electromagnetic fields and all that and apply it to different things. The guys who work on this are doing a lot of things for space. Space, things work differently, and you need to know how the magnetic fields and all those things work there. Communicating in space is different than communicating on air. There's some things you need to know. Control, robotics, and autonomy. Didn't you have that in the other computer engineering? Yes. This one is hardware focused. The other one is software focused. Slightly different. You can have a major or a minor on the other one, okay, or a secondary focus on the other one. Or you can switch from one to the other one on your third year if you really want to. Energy and power electronics, that is my major field. That's actually two big research groups in the department that came together and put that in. That's what's leading the green engineering thing. How you get the energy from the solar panels and get it out, how you get your energy from the wind turbines and put it into the grid. That's what you learn in those courses. Then micro nano systems is how you build ships, and you put a bunch of things in those little ships to do everything you want. That is something that's becoming very strategic, geopolitical type thing, to the point that we're going to move most of those factories back to the US for strategic reasons, right? You also have wireless communication and signal processing. Half of you are looking at your phone and all that, thanks to what? Your wireless communication that you get your signals in here. Just waiting for Virginia Tech to make sure you block it, so when you go to class, your attention is on your teacher, not on your screens. I don't know if we're ever going to achieve that. Now, once you get there, we want to make sure you succeed. And we have a lot of things to try to help you on that. First of all, we have a set of academic advisors, and I have most of the team here, so I have 3 of them. Would you ladies please stand up? They're, they don't have to be here, but they're here because they'll be the ones who are going to guide you through your 3 or 4 years to electrical and computer engineering, okay? And we have 5 ladies who are there helping you all the time and telling you, yeah, be careful with that professor, do this and do that, and all those things, right? We also have other, like career advisors. They will know, okay, I like to work on this field, on green energy and all that. Who can I talk with? They know. They know who faculty you should go and see if you want another information. They also know what resources we have in electrical engineering for you on the labs and the things you can use, and also how to get referral, how to approach a professor and say, can you be my reference for this summer job? Okay, those kind of things, you can get there. And then you have a bunch of opportunities on different co-ops and internships and labs that we have. Have you seen a bunch of students today, and you're gonna see them tomorrow wearing a suit and tie and walking all in a hurry, going to Squires? You know what they're doing? They're looking for jobs. That's a job fair, right? But do you know you also got that to get internships? Companies are coming here, often summer internships. If you go there, you can start looking for it. Maybe you don't have the background they need, but they can tell you, take these classes. Or after you finish this and that, come and talk with me. We're really looking for people like you in any field. So if you have a time, take around, take a look at that. It's something interesting. We also have what we call the AMP Lab. A few years back, it's about 10 years, I used to have senior design groups. One group, I say, what can we do to improve the education for you? And one guy gave me a 1-sentence type response. Say, open the labs. And I say, okay, give me more specific. And he wrote a whole essay on that. And he say, we have great labs, but you don't let us use it unless we take in specific classes. That's wrong. I passed that to the department head. That eventually worked into what is now the AmLab. It's an open lab. We ask you to get some training so that you're safe when you work there, but it's a lab that you can go and use, and it has plenty of things that you can do there, right? And it's used by a lot of the design groups that we have that go into inter-university competition or international competitions and things like that. It's used by our senior design teams. You do a one-year senior design project, you have the labs, and some of the research lab opens to you for that. And we also use by some of the student organizations, right? One of the big ones we have is the IEEE, the Institute for Electrical and Electronics Engineering. It's one of the biggest organizations in the world in terms of profession. It's a worldwide. We're very proud to say that the former president, the one that completed last year, was not only an EE professor, was also an alumni of ECE like myself. So we're really known well nice. Now, where do you work once you finish here? Almost anywhere. This is the electrical energy field, and you don't have to be into an energy major to get there. They need people in computer, they need people in cybersecurity, they need, even in ship scale integration, they need people like that, okay? Same goes for defense. Defense will take almost any fields, even energy, because they gotta power their weapons and things like that. Gaming and entertainment, that's a favorite for many students now, and I hear it's a profitable one. I should have tried. Okay? There's robotics, okay? There's a lot of things are going robotics. Our populations are going down. We're gonna need more automation and things to do things. Cybersecurity is a big thing no matter what. The state is investing a lot in that, okay? 70% of the data centers in this country are in the state of Virginia. That's not only a lot of energy, but that's a lot of things you need to protect on, and also a good source of jobs for things. Machine learning, there's plenty of companies that are going that. Photonics, that's the future, right? The computers, the way we're working with silicons are hitting the limits. Next computer wave may come from photonics, we still don't know. In addition to that, you have grad school. Okay, we're trying to push now our students to do, and we give it a lot of variation. We have a Master of Engineering where you only take classes to get a master, but you focus more on a specific area you want. You Master of Science where you either do a project at the end or you write a thesis. Usually if you write a thesis, it's because you also want to do a PhD after that. And then on a PhD, you got to stick 4 years. When I was your age and all that, I look at that and I went like, I have never me. Here I am, right? You get hooked into things, you really like things, and then you just dive into it and, you know, end up your life doing that. We always welcome officers in the military. As a professors, we like it. Those are usually the best students, you know. They well behave, they do their homework on time, they don't have excuses and things like that. That's the way we want all the students. But they're usually also very good when it comes to engineering, okay? Now, money, which is usually what we want you to know, okay? And there are similar salaries for different engineers here. But the U.S. median salary for EE engineers is $104,000. Computer engineers, $132,000. That's a significant difference, right? Okay? Now, the growth on these fields is about 5% for the next 8 years. This was 2 years ago that they took this data. But it's maybe more than that, okay? Now, don't let those salaries fool you, okay? It's the median value, which is, you know, you take everybody, you take not the average, but the median of the things, and it shows you that. What's more interesting, I say, is the starting salary. For EEs, is $74,000. For, there's an error on the slide, CPE is $69,362, which between the two values there, it tells you there's more variation. So yes, computer engineering, you know, you end up with a big company and all that, you're gonna make it big. But, you know, if you're just okay, you're still gonna make good money on things, okay? It's not that bad. Now, notice the difference between was the median or the starting salary and the starting salary if you come out of Virginia Tech, okay? In electrical, you go from 74, Coming out of here, you go almost 79, 78 on the average. And that's a couple of years ago. And then in computer, 69, but notice how they level. You get computer science degree from Virginia, computer science, yes, but computer engineering degree from Virginia Tech. That salary is almost the same as the electrical engineers on that. It doesn't drop as much. You consider a much better computer engineer if you're coming out of here than much of the universities out there, and that's basically what those numbers are telling you. And the companies, and these are some of the companies that hire on us, know that. They come to the career fair. I get a bunch of emails. We're going to be there. Can we talk in your class? Do you have any students for this? Do you have any other student for that? They really like the way we train our electrical and computer engineers. And I'm sure it's the same with the chemistry and the computer science and all that. They really like the way we do it in the College of Engineers. Okay? To give you a taste of things, the Easy App Lab, if you ever want to come and visit us, we can take you a tour on that. But usually the students do projects on their own. And when they're really good, we say, can we keep it? So we have several projects on the entrance that we should like to show people, oh, the student did this, the student did that. And really interesting things. They went and work on their own by themselves and developed really nice things. Okay? Now, undergraduate research, they have it in chemical engineering, we also have it. We have one of the strongest research groups in the College of Engineering, at least when you count the money on that. You really bring a lot of research money. And we always working with undergrads. So if you want to work with that, after your second year, you're almost ready. You can go to almost any labs. Faculty will be happy to work with you. Actually, to get the grants from the government, they have to hire undergrads as part of it. You know, we make sure they do that. But you learn to work. You learn to work with grad students. That's where you start seeing the grad students, and you go like, well, maybe the grad student is not a bad idea for me. I can do the same thing this guy's doing. Right? But we have those there. There's some of these projects that involve traveling abroad. There is one class we teach in the summer that I think 2004 class next summer is going to be in Peru. Yeah, I mean, I've been there, but still a nice place to it. Now, we have a bunch of design projects that students work on. This is from outside our department. Inside our department, we still have others. We have senior design projects that some of those we come up with, some of those the faculty is doing research and say, I need this piece of equipment, can the student design it? But most of them come from industry. Industry give us the money, give us the project, give us an expert whose job is to talk with the student. We tell the students, that's your customer. You need to talk to this guy. At the end, that's part of your grade. How well are you going to sell these to the guys who are putting the money to get this project? That is as close as you're going to get to an industry experience on a senior design projects. And you're working with a mix of computer and electrical engineering trying to get this done. It is really a good experience on your senior design projects. Right? We have a bunch of organizations for you to join, the IEEE being one of those. Every first Friday of the month, they have Carol Lee donuts there. And if you're in Blacksburg and you haven't tasted Carol Lee donuts, you must, okay? Those are the best donuts you're gonna find in town and probably anywhere else, okay? So if you want, come on Friday. The third Friday of October will be too easy. She doesn't like it because you're gonna eat her donuts, but come and taste our donuts and things, okay? So there's many ways to connect, but if you need more information later on, you have second thoughts and things like that, want to know more, easy to get in touch with us. eceadvice@vt.edu, and any of our advisors will get that email, and we'll get back with you and answer any question we couldn't answer today, right? So thank you, and we pass it to the big guys, the computer side.
All right, how's it going? Whew, yeah. I'm a walker. It's gonna be hard for me to stand still. I'm Dave McPherson. I'm an advanced instructor in the Department of Computer Science. I'm also the Director of Academic Operations, which is a fancy way of saying I deal with logistics, TAs, undergrad TAs, classes, you name it, all kinds of fun stuff like that. I'm also a double Hokie. I started out actually as an EE and then went to math and then graduated with that and then came back and got a computer science degree. So I'm not an engineer. And I say that when I would teach engineering because I used to, actually, so I'm in CS. Before I was in CS, I was in ECE for about 8 years. Before that, I worked as a professional software engineer. Before that, I was in computer science. And before that, I was in grad school. So I've been here a long time. I taught for a long time. It's what I like to do. But I'm here to talk about computer science and what we do. So a couple of you probably are interested in computer science, one or two. We're kind of a small major these days, but anyway, no, I'm kidding, we're huge. There's a lot of you that like computer science. So we have sort of three majors within computer science. So you can get a degree on your diploma, it'll say computer science, that's our traditional computer science. Most students consider that like software engineering, broadly speaking, programming, if you want to give it a colloquial name. Secure computing, so you can actually do cybersecurity, if you will, on the software side of things, and then also data-centric. You might have heard of machine learning, data analytics, visualization, those types of things fall into that. You can actually get, so if you got a degree in computer science with a major in secure computing, it would say that on the degree, on the diploma, so people understand what that means. Those are our three areas. Most of our students are computer science majors, and then maybe 200 or so a piece are in the other two majors. So most people are in our sort of traditional computer science. Maybe you're here and you're thinking, I really want to do chemical or mechanical or electrical or ISE or anything. You can get a minor in computer science. Yeah, it says 53 majors. So not just engineering majors, but English, psychology, chemistry, physics, you name it, English. All of these fields probably have some aspect that could be benefited by having a computer science minor. And so we have a lot of people in minor. We have a traditional computer science minor, again, that sort of software engineering focus. We also have a human-computer interaction minor. We actually have a slide later on that could look like VR or things like that. Could also look like sort of system design or broadly, interface design. And we also share with the EC department the cybersecurity minor. And so you can take classes sort of through both departments to get that minor. So if you're into another area and you want to get a minor in CS, you can certainly do that. We have, last count, I think it was 400, but I think it's more than that. So we have a lot of folks that just decide to do the minor. Yeah, so while you're in CS, we do a lot of hands-on projects. The classes that I teach our intro class, 1114, if you're considering CS and you're going to take that. Although actually last spring when I taught it, I looked at the majors, and over 50% of the people in that class had a declared major other than CS. So they were some other engineer, I had neuroscience, you name it, had all kinds of people in that class. So you'll do hands-on learning, we do a lot of projects. And when I say hands-on learning, it's different than, say, what ECE or chemical engineering, because, I mean, this is what our hands are on a lot, these little laptops. And so it is very project-oriented. I just released a homework for my class today where they're going to write some code and solve some conversions and things like that. So it's sort of that way hands-on, not sort of hands-on building things. Yeah. So within our area of computer science, we sort of have these five broad things that we do. So human-computer interaction, broadly, that looks at how humans deal with computers, how we interact. Why did someone click the wrong button? But it also looks like virtual environments or augmented reality or things like that. So we have we have access with the Cube space over in the Moss Arts Center. They just finished up, I think it was the Cube, COVID, and comics. So looking at the intersection of comics and COVID in the Cube, I'm not exactly sure. Knowledge, information, and data, right? Most people hopefully recognize that we use computers to find things out. And so how do we do that efficiently? Media and creative computing, so using computers to do not just software engineering, but how can we be creative with them? Scientific computing, and then systems and networking. So those are sort of 5 broad areas of how we look at computing. In the department, you can take courses that kind of focus you if you're interested in a particular area, and so then as you graduate and you're looking to do something, someone can recognize a track of courses and say, oh, I see, you broadly are into systems, which is like operating systems and things like that. People often ask, what kind of electives do you have? So our freshman and sophomore year are more or less the same, but in your your junior and senior year, your third and fourth year, you can start to take electives. So these are some highlights of electives that people like to take. Mobile and software, right? Everyone's got phones these days, so whether it's Android or iOS, we have classes in how you can actually code those things. Cloud, right? Cloud is huge. Everyone wants to put everything in the cloud. Intermediate software design, so the idea of how do you efficiently design software so that it's hopefully bug-free and things like that, and how do you do it better? So that's what that one is. Software reverse engineering, which I think is kind of fun. So how do you take a running application and figure out what it does? Does it do bad things? Is it secure? Things like that. GUI and graphics. So GUI, if you're not familiar, stands for Graphical User Interface. So how do you actually design one of those or code one of those? And then just computer graphics broadly, so not just GUIs and things like that, but if you were making a video game, how do you do ray tracing? How do you do those types of things? So these are some, these are based, I think all of these are on the junior year. You can continue to take electives. Most of these here are on the senior year, so that machine learning, artificial intelligence, database management, those are all super popular. Actually, that computer systems and Rust is brand new. That is at the junior year. We're looking at the Rust programming language, if you're familiar with it, and how we can use it in our operating systems course. Computational biology and bioinformatics. Starting a CS business is one that we're just sort of launching, so some of you may also be interested in your own business. How can you do that successfully? And then algorithms in society. So we're looking at, we've got an instructor here who looks at the connection between, not the how do we do things, but why do we do things and should we do those things? And the little I'm a robot there was, if you ever done the CAPTCHAs, like find the bikes in these pictures or find the fire hydrants in these pictures, you're training a machine learning model to recognize things, sort of what we were talking about earlier, like how do we know what's what? Well, we're all training the machine learning model. This actually is a picture of an HCI senior capstone. So that's one of our advisors there. She's sitting in the chair. I think she's holding a controller with a headset. So this is the kind of thing that you might do if you got into HCI, looking at, this is a virtual environment, an immersive environment, so looking at that. So sort of like the senior design that ECE has, we have capstones in these areas that are related to sort of the disciplines that we have. So systems and networking, secure, multimedia, and so on, data-centric, software engineering. And as a senior in CS, you would choose one. I'm the, what's the word? I'm the sponsor for a project for our department for building a system to work with our TA application process. And we have other industry clients, we have other clients from our department and outside of our department that deal with somebody needs something software related, and that's sort of the gist of it. I think they said they got a one-liner. Fix this spreadsheet was what they were told to do. But yeah, so we do those things when you get to your senior year. Master's program, we do have two if you're interested in that kind of thing. We have one that is a coursework only. That's that Master's of Engineering. Most of those students live in Northern Virginia, but not all. And then we have our traditional thesis-based master's degree. If you're looking to do a PhD one day, you would want to do that one. If you're looking to go get a job and be in industry, you probably want the MEng because it's going to be more related towards working in industry. But you can actually, I think we have a 4-year, 5-year program where you get your BS in 4 years and finish with your MEng in 5 or maybe 5.5. I'm not sure if the MS thesis goes into that 5-year accelerated, but I know lots of students get into that stuff. Hacking, a lot of people like to do it. This weekend actually is the VT Hacks. A lot of industry come to that, and there's industry panels and industry 101s, there's hacking 101s. So a lot of students will go to these just to sort of learn things. There's prizes involved. and all kinds of fun stuff like that. There's also Hack Violet, which takes place in February, very similar. Industry comes, panels come, teaching, all that kind of fun stuff. Teams get involved. I think, I could be wrong about this, but I think VT Hacks is in Castle Coliseum this weekend. You're welcome to wander over there and take a look at it. I think it's Friday, Saturday, and Sunday, if I remember correctly. Outside of those, we have other student organizations. These are the 6 that we have that are related with the computer science department. There's some others that haven't filled out their paperwork. I'm trying to get them to start a rec club this weekend. I've convinced the department for some reason that it was a good idea to sponsor a pickleball tournament. And so we're doing that on Saturday. But if you've looked at the weather, they're calling for this little hurricane to come through, so that may not happen, unfortunately. But anyway, so I'm hoping we can sponsor that into a student recreation club to get away from these screens from time to time and do something outside with other people. But yeah, so we have these things, AWC, which is Association for Women in Computing, Girls Who Code, Data Structures and Algorithm. I think I'm the faculty sponsor for that. Tech Hackers, Color Stack, and CS Squared. We also have some study abroad opportunities. The one on your left is about a week-long study abroad in Egypt, I think that one is. And the one on the right is a semester-long study abroad in Switzerland. So if you're interested in study abroad, we have those opportunities. We started with just a week-long, and I think last year we did one after the semester, and now we have both a week-long and a whole semester study abroad. I think that takes place in the junior year, if I remember correctly. We also have research. So we have 4 different centers there for doing research if you're interested on the left-hand side. And then on the right-hand side, those are our 10 sort of research areas broadly laid out in terms of, and I need glasses for these because those are tiny. Computational biology, data analytics, that's your machine learning. Digital education, we actually have a really strong digital education, computer science education faculty group here if you're interested in that kind of thing. HPC, which is high performance computing, human-computer interaction. You could, again, think of that as some of the AR, VR stuff. Mathematical stuff, I was a math major, I like math. So if you're into the theoretical side of things, we have that for sure. Security, software engineering, systems, which again, you could think of like operating systems. And then that new one called quantum, which is really cool. We've just hired 2 or 3 new faculty in the last couple of years in that area, and we definitely have a growing interest in quantum computing. Getting hired. Most of you are here, I think, to get a job eventually when you graduate. That's the plan, at least. And so we have several different things that we do here. Oh, yeah, the left thing, the Job Hub, we actually have a CS Job Hub where you can go and see who's looking for interns or jobs. Yesterday, I think, was the CS Job Fair that was geared directly towards CS majors and CS minors. You have to be one or the other to go to it. We have partners, some of those there that are listed, the American Systems, RGI, Patreon, CoStar, and so on. CoStar you probably haven't heard of, but if you've ever seen a commercial for apartments.com, that's them, and they're in Richmond. And so they are a faculty or a partners, industry partner with us, and you can talk to them, Bloomberg, MITRE, and so on. Other people you may have heard of, Geico, Capital One. Oh, there's a resume workshop. This is with an alum, Geico resume workshop, and so on. So we have lots of resources, lots of industry partners that want to hire you, that want to bring you on board, both from all over the place, from finance to security to games, you name it. What can you do? Right? You can do all kinds of stuff. Like most of these degrees, that sort of opens the door to all kinds of things. Cybersecurity, aerospace, music, computers you probably recognize are in almost everybody's lives these days. Fun fact there, Dan Lavery was actually an alum and helped design the Mars Sojourner rover, which I think is kind of cool. All right, we have lots of fun. Come take pictures when you graduate and be in touch.
Excellent. Sorry, I spooked up on you on the other side. So what we're going to do now is we're going to turn it over to you all to have a Q&A panel. So those of you who are going to sit on stage, feel free to come on up, and you'll sit with your tablecloth. So we'll have chemical, electrical and computer, and then computer science. So the first question that we have tonight is, why should a student consider your major? And we will start with chemical engineering. Sorry, chemical engineering.
Hello?
Yeah.
Oh, okay. My name's Sarah Miller. I am a senior studying chemical engineering. I'm a fifth year, so I actually co-opt at a couple different companies, but I think I'll talk about that a little bit later. So why should you consider chemical engineering? My biggest piece of advice to you for considering chemical engineering is, if you like problem solving, that's why you're in engineering. If you like to scale things up, if you have an interest in chemistry, if you have an interest in just how things that you see every day work, like how do you get gasoline? How do you get that out of the ground? How do you process gasoline? How do you get fuel in your car? How do you make medicine? If any of those questions interest you, I would suggest considering chemical engineering. It's a very broad major. I have a couple friends that actually went into banking after they got their chemical engineering degree, people that go into food, consumer goods, pharmaceuticals like was mentioned, but even like semiconductors and things inside computers. Chemical engineering would be the place for you.
Wait, is this good?
Yeah, you can sit back though. You don't have to.
Okay. Yeah, for the electrical and computer engineering department, I love it, honestly. I'm Yuri and this is Stan, and we're both ambassadors. And the reason we're ambassadors is because we love what we study and we love the department. We have a lot of hands-on opportunities. The first 2 years, the bunch of classes you take, you're gonna have a lot of different labs, and then integrated design project on your second year. And they also give a lot of opportunities outside, such as research and the design teams that they talked about. But overall, computer and electrical engineering, it has a lot of good job opportunities in many different areas. Coming into college, I did a lot of research, and of all the engineering majors, I saw that computer and electrical engineering are up there for job prospects, and also it's where the future is. There's a lot of innovation related to electrical and computer engineering, and yeah, that's where I want to be. I want to be over there making cool stuff that's going to change the future. So.
Yeah, like you said, my name is Tanner Casto. I'm an electrical engineer. I think students should consider electrical because if you have any question about how electronics work, if that interests you at all, or if you have interest in physics and how all that all works, you really get to dive deep into that. But in the EC department, it's real nice too. You get to have a background in the software side, the computer engineering, as well as the electrical engineering the first 2 years, like Dr. Centeno was saying in the presentation. But like you were saying, there's a lot of job prospects at the career fair today. I got pulled into a couple booths that were begging me to have a job with them. So I don't think it'll be hard to get a job. So I think that's a lot of good reasons why you should join ECE.
I'm William Tuck. I'm a computer science sophomore here, and why you should consider CS? Well, first of all, the first thing everyone thinks about is money. Very lucrative, but money comes with the fact that we are very versatile individuals. So you can go into cybersecurity, you can go into national security, which is what I personally am going into. You can go into, even with software development, game development, things like that. So if you're not into the front end aspect, but you want to consider how do you create games, how does the computer work, how does the mind work, and how does it work with our friends over in ECE with their hardware, how do those things combine to work together? It's a really good opportunity. And then also, since it is so versatile, it's very easy to play into another major. So for example, I'm a criminology second major. It plays directly into criminology because law enforcement, cybersecurity, it plays right into each other. National security, it's a big issue that'll never go away. Even if AI takes over all of the coding jobs, as people say, you don't have to worry about that if you go into an industry where you are the only person that can do what you do, or you specialize in something that a computer cannot do. There you go. You don't have to worry about being replaced. So that myth of being replaced by computers isn't necessarily true, but also at Tech, since we are a general engineering school, you work with other engineers and learn how you can use your major to contribute to your future career.
Okay, so I'm going to turn it back to you over in computer science for the next question. And these questions were provided in advance, and so word choice was always from the audience as well. Is what was the neatest aspect of your undergrad experience that you have taken advantage of?
Honestly, for me, it's not even specific to computer science, it's just engineering as a whole. We've had great opportunities here with extracurriculars. Me in particular, Engineers Without Borders has been something I've really enjoyed. It's a place where we can work with other engineers. It's a very civil engineering heavy club, but we encourage everybody, including non-engineers, to join. So for example, I'm computer science. I know nothing about concrete, I know nothing about statics, nothing about footings, building code, any of that. I've learned that through those opportunities, and it helps you get experience in other fields, because as a computer scientist, you can't write an algorithm for an ECE major or a biochem major, pick whatever you want. You can't write an algorithm for them if you don't understand what they need done. So it's one of those things where at Tech, since we have such a variety of opportunities, you get to work with different students in different fields. And then, like I said, computer science in particular kind of plays into every field. As our presenter was telling us earlier, there's multiple fields where there's always some bit of computer science. Even if you're a teacher, you have to know some bit of computer science just to be able to implement lesson plans with your kids. If you're working in a coal mine, you have to use computer science to look at the geographical maps, which are handled then by other majors. So you have to know, when you're coding those maps, how does it play into the geography and the rocks and everything. So that's something that's very important as well.
Yeah, so the neatest aspect of my undergraduate experience, so for ECE, I'm a junior, so this is my third year. So the coolest thing that I've probably gotten to do is just learning all I have in these short 2 years on my own time as a personal project and building the radio from discrete components. So I think just having 2 years of schooling, just kind of having that foundation software and hardware, and then be able to do that and kind of understand what you're doing, that's pretty neat. The EC department has some cool events too. Like they have picnics every year. They have donuts and coffee, like it was mentioned in the presentation. So, you know, we're not all just books, you know.
Yeah, there's also a good amount of research opportunities that I decided to take advantage of. When I was a freshman, I applied for a robotics laboratory, and that gave me a bunch of hands-on experience that helped me 100% get my first internship. Without that lab experience, I would never have landed an internship after my sophomore year. So just the hands-on experience that you can get both from research labs as well as design teams was definitely something very special that put me a step ahead of a lot of people.
I've got to do a couple really cool, neat things while I've been studying chemical engineering. I've been paid to move to a bunch of different places. I got paid to move to Texas. I got paid to move to Raleigh, North Carolina, and get my hands on some really cool equipment and some really cool processes. But by far, my favorite and coolest thing I did was, like Jeremy mentioned earlier, we have to take a unit operations lab that summer before your senior year, and I actually took it in Denmark. I studied in Copenhagen for the whole summer. Instead of being in Blacksburg, I took a break. I went to Europe. I had my Euro girl summer. I got to travel around to a bunch of places that I've never been before. I'd never left the country before, and this was a great opportunity for me to do it. Instead of being in Blacksburg while you're working on the lab, which is great, but if you're working on a lab really hard, when we finished our lab work, we went to Sweden. And then we came back for the day. And then we did another lab, and then we're like, oh, where do we want to go to next? And it was just a great opportunity to learn, but also to have fun with my friends and fellow classmates in my major.
Exciting, exciting. So we'll start with electrical and computer engineering tables tonight for the next question. As students are trying to determine the best major for them, what is the one piece of advice that you would give them to help make that decision?
I would say definitely don't close your mind really early on. I have had many different ideas of what I wanted my career to look like. And right now I have an idea, but that could change in a month or even a day. Like, you're still learning a lot. You're going to go through many experiences. So just don't close your mind to different majors, different topics that you're interested in, because there's a lot more out there than you think. So just be curious and be always open to learn, and don't be scared to change what you want to pursue for the rest of your life.
Yeah, I agree with that. I started out in computer engineering. I went through the first 2 years, did those computer engineering classes. They weren't particularly for me. I enjoyed the EE side of everything, so I switched my focus to electrical. But just kind of having in that open mind and not being set on one thing. If you get 2 years through the EC degree, you don't like it at all, go to CS or go to chemical, go to aerospace. So really, as an undergrad, you have that flexibility, and I think that's what's really nice.
My biggest piece of advice to you guys would be to talk to different people. Similarly to them, I came in as a freshman thinking I was going to do something different. I came in as an aerospace engineer. Obviously, I'm not there now. Talk to different people, talk to your professors, but also most of us up here are ambassadors, and all we do is talk about our major and how great it is. If you reach out to like an academic advisor or somebody in the department that you're interested in, it doesn't even just have to be us. They have advisors that would be more than happy to talk about you more in depth than we're going into tonight, with special careers and special things like that and different opportunities that we've already had. So I would definitely take advantage of that.
Yeah, I mean, as they both said, it's not set in stone. I came in dead set on computer science all through high school. I did cybersecurity. That said, I have not done a single thing that has to do with cybersecurity here at Virginia Tech, and I don't think I will in the future. So I thought this whole time I wanted to be a white hat hacker. It sounds so cool. And then I came to Tech, and I got involved in the Intelligence Community Scholars Program, and my mind completely changed already, and I've only been here a year. So the likelihood my mind changes again is very high, and like I said, it's not set in stone. Figure something out that you enjoy. If you don't feel like you want to do it your whole life, that's okay. A lot of people don't even know what they want to do next year, let alone their whole life. So just give something a try. I've always heard from people that it's better to start out in something that's generally on the path that they want, rather than to stay in a general engineering position where they kind of just take gen eds and then they're forced to take a class that relates to their major and they're stuck in it. Because right now, I'm taking classes, some of them relate to my criminology degree, some relate to CS, some of them are just electives. And if I were to change my mind from CS, now instead of having all my general education credits done, pathways we call them here, I can change it up a little bit if I really wanted to. I don't foresee that happening, but I've only taken about 5 CS classes rather than now I have to take 3-4 CS classes a semester, and now I'm stuck unless I want to take more years, because I don't want to take more than 4 years of college, but I also know that sometimes that has to happen, so you have to understand like the balance of picking something early with also understanding that you need to get done within your time frame. If it's 6 years for you, it's 6 years for you. If it's 4 for you, some people it's 2.5. So it really all depends on everybody's individual plans.
Yeah, I would just add, as thinking about computer science, I teach a lot of freshmen, a lot of sophomores, a lot of juniors. Successful computer science majors tend to be ones that like to solve puzzles. And I'm talking like jigsaw puzzles, and like the 5 people ran a race and this person came in first and that person came in second, and so, or like the tall person came after the short person or whatever, those kinds of puzzles. If you like that kind of stuff and you like thinking about things, you probably will like computer science. Probably. You might not. But my experience has been students that enjoy solving puzzles and thinking about puzzles tend to like computer science and tend to be successful. Not everybody, but tend to. So that's my 2 cents there.
Anything else anyone else would like to add? Okay. One piece of advice. Okay.
I'll just jump in real quick and have my old man moment. There's not a wrong answer. You can change your mind. I've changed careers 3 times and I'm 32. So you'll figure it out.
Excellent. Thank you, Jeremy. So for our last question of the evening, we'll start with you at chemical engineering. We are going to say, what do you wish you had taken advantage of during your undergrad experience that you reflect on now that you wish you had?
So a big thing about chemical engineering specifically is we have a really supportive student body. Your peers are going to be really supportive of you. It's very collaborative. It wasn't there when I first started, but since then the ASHE chapter has started their own tutoring group that the professors know of, and they get a room and they all go there and you can tutor. They have upperclassmen in every single class that'll tutor in all of the specific chemie classes. You can also get advice for like, what class should I take? Should I take it with this professor? And some people will be like, no, please don't. And they'll tell you exactly who you should take the class with. And the tutors, they know their stuff. Like one of the guys that started the tutor program is now getting a PhD at MIT. So they're very well educated and they can help you out tremendously. And had I had that in the beginning, I think it would have helped in some of those core foundational classes.
I would say for sure, just kind of going along with what you said previously, just talking to people who are ahead of you, people who have graduated or maybe are a couple of years ahead of you, just getting information from them, learning from people who already been walk the steps that you're going through right now. It's really, really valuable to get insight from people who've been through what you're going through right now. So just going out there and talking to people and asking them about their experience and for any possible advice they could give you and making connections that could also help you down the line, for sure.
Yeah, networking is a big thing, especially with the upperclassmen. I would say take advantage. I know all of the engineering disciplines, they have research and design teams. Take advantage of that. I think with any kind of engineering, you're learning a lot of theory. You're learning a lot of things that are models that are ideal. When you go out and actually do it, it's not going to be ideal. So I think it's really important to exercise and having those experiences where, oh, this is not what we talked about in class. It's similar, but you know, that will really help you going into your career and getting a job, because employers like to see that, oh, they know both sides. They know what they've learned in school, and they also know how it actually works and how it actually happens.
So I'm 19 years old, so I haven't really had my full undergraduate career, but something I already have regretted is not doing study abroad earlier in my time here, because now I'm at the point where I have so many commitments that I barely have time to go home, let alone go overseas. So I would definitely say if you want to study abroad, consider it early. It doesn't have to happen early, but just make sure you have a plan for that, especially in your classes, because you can't always take the same classes abroad that you can here. And then something I'll speak on for my friends that I've seen, especially my upperclassmen friends, is a lot of people do not get involved in things that do not relate to engineering. So I know this is an engineering expo, or Explore Engineering Week. Expo was earlier today. Explore Engineering Week, it's for engineers. Don't just be an engineer. Be a good person. Be somebody in the community. For example, I do College Mentors for Kids. I go there once a week. It's a 2-hour commitment. I work with a kid. I have my own little buddy. We have a great time. You make a difference in the community. I'm part of the Red Cross as well. Go out there, reach out. It's free to give your time. You might not always make money, but honestly, I think with my internship offers, it has come from my extracurriculars, not my classes, because every single person in this room is going to take similar classes, whether you take a 5,000 level class or a 4,000 level class. The federal agencies or the Lockheed Martins of the world are going to look at the kind of person you are as well, especially when it comes down to security clearance time. If you go and work with children once a week, or you are part of the Red Cross and you already do things where you're under confidentiality agreements or background checks, it goes a long way, rather than you are on one engineering design project and all you do is ECE or all you do is computer science and all you live and breathe is your computer. It really makes a difference getting out there in the world and being part of the community. There's so much to see around here and so many great people off campus. Go see them.
Excellent. Thank you all so much for being here tonight and for addressing all of those questions. So what we're going to do is you can lower the screen. Give the panelists a round of applause. And you all are free to leave. And what we'll do after our panelists leave the stage, many of them will be at the tables in the back of the auditorium, like in that first level, that mezzanine level. So feel free to, if you have some questions you didn't get addressed tonight or things that you wonder, please make sure that you ask those. We won't stay around all night, but we will stay to address many of your questions. And then what will happen too, I will pull up the QR code in just a few moments, but just what I need like you're told it's not ready. The guy's got to come from the upstairs to down to open the screen, so it'll take just a second. But what we will also do is make sure that you do get all of those things addressed. You will be able to fill out a quick survey for your class attendance if you are here for your Engineering 1215 or 14 class assignment. And so if you can't access it from the very back, just come forward and scan the QR code that way. You're welcome. Thank you very much. So I want to thank you all so much for being here tonight. Have a good evening.